him to lead us in prayer.
Let us put ourselves in the presence of the Lord. Our Heavenly Father, we offer you our thanksgiving. We thank you for everyone gathered here today to walk with you. May we ask you for your blessings and guidance so that the activities set for this undertaking be successful. We ask you to open our eyes to see the wonderful things from this activity. We ask that you open our ears so that we may retain a valuable knowledge. Open our minds for us to think wisely. Put us with understanding, cooperation, and peace in fulfilling our responsibilities. Open our hearts so that we may receive your everlasting love, and open our spirit so that we may know that you are with us all throughout the day. We ask all this in the name of Jesus Christ. Amen.
Thank you for the beautiful prayer song. A very good morning to everyone and a warm welcome to all gathered here today. It is with great pride and pleasure that I welcome you to the second day of ICRTMCS 2025. To begin this session, let us welcome our dignitaries for the second day.
May I invite Ms. Emuna, Assistant Professor, Department of Mathematics, to introduce the keynote speaker and formally welcome her to the second day of ICRT MCS 2025.
It's my great honor and privilege to extend a very warm welcome to our distinguished keynote speaker, Professor Dr. Intan Daitina Mustadi, who is joining us online for this conference. Professor Intan is a renowned mathematician and educator with a remarkable academic journey. She completed her bachelor's and master's degrees at Institute Technology Bandung, Indonesia, followed by another master's degree and doctorate from Université de Picardie, France. Her career has taken her across the globe with research positions at the University of Leicester, UK, and Tokishimon Bandri University, as well as being junior assistant at ICTP Italy. Currently, she serves as a faculty member at Institute Technology Bandung, Indonesia, and her research interests include algebra, cryptography, and coding theory, and artificial intelligence, fields of immense significance in the present academic and technological landscape. She has also made exceptional contributions through leadership, serving as the president of the Southeast Asian Mathematical Society 2024 to 2025, vice director of the Accreditation Agency for Higher Education in Natural and Formal Science 2022 to present, president of the Indonesian Mathematical Society 2016 to 2018, vice president of Southeast Asian Mathematical Society 2018 to 2023, and president of the Indonesian Algebra Society 2011 to 2018. On behalf of the organizing committee of ICRTMCS 2025, we are truly delighted to welcome you, Professor Intan, as our keynote speaker. We look forward to your enriching talk and the valuable insights you will share with us through this online session.
Thank you, ma'am, for your warm words of welcome and facilitations.
Ma'am, ma'am, we have already made you as a co-host. You can start sharing your screen, ma'am.
Okay. 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 Thank you very much for the invitation. It's my pleasure to present my work in this international conference. Hopefully, I can come visit in person. And today, I will share. Wait a minute. Where is it? Um, okay, can you see?
Yes, ma'am, we can able to see that.
Okay.
Ma'am, it's possible to make it in a full screen mode, ma'am?
Wait a minute. Is it good now?
Yes, ma'am, now it's fine.
Okay. Okay, so good morning. Thank you for the invitation. This is a joint work with my student Luki Cahyawan Ditra and my colleague Delavita Nasution. We are from Institute Teknologi Bandung, Indonesia. And the title is Artificial Neural Networks Using Quiver Representations of Finite Cyclic Group. I will start with the neural network. So what is neural network? So artificial neural network is a mathematical model of network with neurons. And this is different from biologic neural networks, which is more complicated. So in this artificial neural network, it will consist of input and then some layers. And we put the input here, we calculate, and finally we will get the output. So neural network are layers of neurons which connected by edges, and each of these neurons is assigned to a value which depends on the previous layer, except the neuron in the input layer. For the other layer, each value in a neuron in that layer is the value of a function that we call activation function. The activation function takes the values of the neurons of the previous layer, values assigned to each edge, which connect a neuron in the previous layer to that neuron. We call it weights, and a value called a bias as its input. In order to perform its task, a neural network must go through a process called training. The goal of the training process is to find the optimal weights and bias to perform a given task. This is done by initially assigning random weights and bias and provide the neural network with some data set. Then we find the weight and bias which provide a minimum value of a chosen cost function through a process called backpropagation. So, and the application of artificial neural network can be seen as the medical application, information research and retrieval, in business and management, education, also in chemistry. And let me explain about the input layer and then the hidden layer and then the output layer. And for each edges here, we will put some weight, and the task is to find the optimal weight so that the machine can recognize the input that we put here. And then, like I mentioned before,
we find the weight and bias which provide a minimum value of a chosen cost function through a process called backpropagation. But what I will explain today about this process, for example, here, let's say we have input as these numbers x1, x2 until xm. And for each edges here, we put some weight and we also can add some bias here. And then we have this summing function. It means we multiply x1 with w1, add with x2 with w2, and finally xm with wm. We add all of them, and then we add with the bias, and we put the activation function on this sum, and we will get the output. So the neuron is the basic information processing unit of neural network. It consists of a set of links describing the neuron inputs with weights W1 until Wm, an adder function or linear combiner that computing the weighted sum, like I explained before, U will be the sum of Wj times Xj, and the activation function phi that we compute the phi of this U plus this bias. This for limiting the amplitude of the neuron output. So the activation function can be, for example, this hard limiter or piecewise linear or this sigmoid or hyperbolic tangent. In deep neural network, we can have many layers like this. For example, there are 5 inputs here and 4 layers, and then output 1 until 5. For example, if the weight is 1, 3, and minus 2, and input is 2, 0, and minus 1, so the weighted sum will be 2 times 1 plus 0 times 3 plus minus 1 times minus 2, and the result will be 4. But then we put this activation function f, for example, ReLU, which is maximum of 0 and x. And in this example, we get 4. So the ReLU of this x is 4. If we change the input, for example, 1, minus 2, and 0, and the weight as 1, 3, and minus 2, so we will get the x is minus 5, but the ReLU of this will be 0. So that's the one example of the activation function. In this example, we see the ReLU. Now I will explain about quiver. Quiver basically is a directed graph. Consists of the set of vertices, for example, 1, 2 until n, and set of arrows that we call it Q1. And these two functions S and T, you can say as the starting point and also the target. So an arrow alpha will start at S alpha and ends at T alpha. For example, this arrow alpha 1 starts at A0 and ends at A1. So A0 is the S of alpha 1 and A1 is the T of alpha 1. We also define a non-trivial path as a sequence of arrows alpha 1 until alpha L that satisfy the source of alpha I plus 1 is the target of alpha I. These are example of quivers. We call it quiver to distinguish with directed graph because we allow to have multiple arrows like this or this, and also we allow to have loop like this. Now I define a quiver representation. A representation of a quiver Q is given by, for all vertices in Q0, we put a K vector space MA. For any arrow alpha from A to B, we put linear transformation MA to MB. A representation is a finite dimensional if the dimension of MA is finite for all vertex A in Q0. And a thin representation is a representation where the MA is all the vector space complex numbers. It means dimension 1 for all A in Q0. For example, in this quiver, we have a thin representation where we put, for all vertices, we put the vector space complex number C, and this W alpha 1 until W gamma 4 are all linear transformation. We also put this function FC until FG, which will be the activation functions. So a quiver Q is arranged by layers if it can be drawn from left to right, arranging its vertices in column such that there are no oriented edges from vertex on the right to the vertex on the left. There are no oriented edges between vertices in the same column, other than loops and edges from bias vertices. The first layer is called the input layer. The last layer is called the output layer. The layers that are not input nor output, it's called the hidden layer. We enumerate the hidden layer from left to right as the first hidden layer, second hidden layer, the third hidden layer, and so on. So basically, we want to model the neural network into this quiver representation, as here is the input vertices and this output vertices, and a subset of these source vertices are called input vertices. Source vertices that are not input vertices are bias vertices. For example, this F is a bias vertex. And all the sink here is called the output vertices. All the other are called hidden vertices. A network quiver Q is a quiver arranged by layers such that there are no loops on the source, no loops here, nor loops on the sink, and exactly one loop for each hidden vertex. And we define the D-loop quiver is the quiver obtained by removing all loops. The weight between two neurons is used to multiply the output signal of the first neuron, and the result is fed to the other neuron. Since multiplying with a number is a linear map, we get that a weight is used as a linear map between two one-dimensional vector spaces during inference. Therefore, the weights of a neural network define a thin quiver representation of the D-loop quiver Q0 of its network quiver Q every time it computes a prediction. When a neural network computes a forward path, we get the combination of a thin quiver representation and also activation function. So a neural network over a network quiver Q is a pair W and F, where W is a thin representation of the D-loop quiver Q0, and F are the activation function, which you can see here from VC to VG. And now we define activation output. So basically, this is the result after we put the numbers like we did here. Like we have as the input 1 minus 2 and 0. And then we multiply with these numbers. And then we put this activation function. You get either 0 or in the previous example, you get this 4. So this activation output basically compute all from the numbers that we put in the input. And then, for example, you have this number here, XA and XB. And then you multiply, you put this linear map W alpha 1 of XA, put the F which is here, and then you add with F which is here, FD of W alpha 2 of XA. And then if you want to see what will be here, it will be FF of W beta 1 of F of FF FC of W alpha 1 XA and so on. So for example, if you want V to be C, so it will be FC of W alpha 1 of XA. And if you want V equal to D, which is here, will be FD of W alpha 2 of XA plus FD of W alpha 3 of XB. And finally, this will be the longest one as the output. And the formula is given like this. So basically, this activation output is computing all the input multiplied by the weights, and then we put the summation and so on and put the bias like we did here. But it is more complicated because we have many hidden layers like we seen here. Okay, I go back. Now I want to define a morphism between two neural networks. So here, by making a representation of neural network, we can define function between two neural networks, and we can also define morphism of neural networks such that between this to another neural network, this will be commutative. It means the composition of GV with tau V is the same as tau V with FV. And we call as an isomorphism, if it is an isomorphism of quiver representation, it means all the TV here are isomorphic. For example, if we have the network quiver W like this, which is C, 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 and C, and the quiver look like this. And we have another network quiver U, C, 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 C like this. And then we define tau 1 from this, for this vertex, tau 1, tau 2 for this vertex, tau 3 for this one, and tau 4 for this one. So basically we have two neural network, and then we define more map from this network quiver to another network quiver with the same quiver. And this must satisfy the composition. For example, U alpha tau 1 must be the same as tau 2 W alpha, like I mentioned here. And the notation is U equal tau dot W. And if each tau1 until tau4 is an isomorphism, then we say that W and U here are isomorphic. So the importance of seeing two isomorphic network giver is this theorem. If these two neural networks are isomorphic, then the activation output is the same. It means when you have two neural networks which are isomorphic, then the output result which is here will be the same. It means there are infinitely many neural networks with the same network function independently of the architecture and the activation function. It means we can choose simpler one, for example, with the weights which are more maybe smaller, easier to compute. And if this one is isomorphic with this one and this one is simpler, then when we want to compute the output here, it will be easier and we can get the same output for W if this W and U are isomorphic. Now, if we change the C with CG, CG is a algebra group of a finite cyclic group. So basically, in the previous slides, we put from these vertices A1 to A10 are the C of dimension 1. Now we want to see whether we can change into something with higher dimension. And this CG has dimension the number of element in G. And since this is higher dimension, so the linear map from T epsilon 1 until T epsilon 21 will be all matrices. And the CG is all the function from G to C. And we have this operation for two functions, Fg is defined like this, and also scalar multiplication. And also we have this convolution operation. And so for example, for the activation output will be the same way as we had earlier, but now it's just this W epsilon 1 until W epsilon 6 are matrices. And the how to compute the output here is the same as before. And we have the same result as before, that if these two neural networks are isomorphic, then the activation function also the same. Now, how about the recurrent neural network? Recurrent neural network means from the last hidden layer, there is a map to the first hidden layer. So not only going from the left to right, but there are some vertices that going from right to left. And we call it a recurrent network weaver is if it is augmented by arrow from all vertices on the last hidden layer to all vertices on the first hidden layer. We call it recurrent neural network. And we should distinguish the arrow that the source is on the left and also the set of arrow that the source is on the right. So for example, for E hat, it is with the weight W1, W2, W3, W4, and W5. And for E bar is this W6. And we once again compute the output, but now we can also have a map from this to this given by W6. And it turns out that we can also define this activation output like before. And we have the same result that saying for two isomorphic neural network, the activation output also the same. And for future research, we want to see application for this artificial neural network and recurrent neural network. And also, if possible, combine the topological data analysis and quiver representation for machine learning. These are the references. Two of them mentioning the result that I explained earlier. Artificial neural network using quiver representation of finite cyclic group and representation theory for the recurrent neural network. So thank you for your attention. Any questions?
Are there any question or clarification from the participants?
Yes, ma'am. There is a one question.
Okay.
Ma'am, can you please elaborate about the significant differences between artificial neural networks and deep neural networks with the connection of the cyclic group of Q representation, ma'am?
Okay. So let me explain again. So basically what we're dealing is this one, the deep one. It means there are not only one hidden layer like in this picture, but we are dealing with something which is like this, with many hidden layers. So it is in the deep neural network. So it means to compute the last output here, we'll be dealing with many arrows which are here. And what I want to say is that if we have two neural networks like this, and then between these two neural networks, we have a map that is an isomorphism, then if the other one is easier to compute, then we can use the one that easier to compute to get the output for this one. And for the cyclic group, we try to change this all C here with something which is higher dimensional. For example, as the input, not only numbers like we have in this example. Wait a minute, which example? This example, the input only number 1, -2, and 0, and then the weight only this number 1, 3, and -2. But we want, for example, if we want as an input, maybe the RGB number, the red, green, and blue as the color, and it means it is in 3-dimensional, and then this is like a vector of length 3, and the output will also be a vector of length 3. And then when you multiply this, you need a matrix, a 3 by 3 matrix. But the result turned out to be the same, that when we make with the higher dimension, and if we have a neural network isomorphism, and the output will also be the same. And the advantage of using a finite cyclic group is that we have this convolution function. Where is it? This. So it means that we can also choose for the multiplication between two elements in CG, and so that for the matrices that are here, we can choose a special matrix, for example, like circulant matrix, where the input of that matrix not, for example, if the matrix is 3 by 3, so for the storage you only need to storage three numbers, for example, like that. So the advantage of using finite cyclic group is we can arrange so that the matrix as the weight matrix can be a simpler matrix that don't need big storage. I hope that explain your question.
Yes, ma'am. Yes, ma'am. It was clear, ma'am. We believe that definitely this could be the good technical terms, at least for the students to know the real applications by connecting with the neural networks and deep neural networks with the existing topics of the algebraic structures. Thank you so
Yes.
much, ma'am, for your nice presentation.
Thank you.
Thank you so much, ma'am, for your excellent presentation on artificial neural networks using QR representations on finite cycling groups, and for sharing your valuable knowledge and expertise with us today.
We are truly grateful for your presentations and your presence with us online. May I now invite Ms. Renelda ma'am to propose the vote of thanks to our keynote speaker.
It is indeed a great privilege to propose the vote of thanks for today's keynote session. On behalf of the organizing committee of ICRTMCS 2025, I extend a heartfelt gratitude to Professor Dr. Intan Daitina for graciously joining us online and delivering such an insightful and enriching keynote address. Your valuable thoughts on algebra, cryptography, coding theory, and artificial intelligence have truly deepened our understanding and inspired us to look at these fields with renewed enthusiasm. We are truly deeply grateful for this time and effort you have taken. Despite many international responsibilities, to share your knowledge and expertise with us. Your words will certainly motivate our delegates, researchers, and young scholars to strive for excellence in the academic and research pursuits. Thank you once again, Professor Intan, for your generous contribution to this conference. We sincerely hope to have more opportunities in the future to interact with you and benefit from your profound expertise.
Thank you.
Thank you, ma'am, for your vote of thanks. Participants,
Thank you, ma'am. Thank you once again, ma'am. On behalf of our organizing committee, ICRTMCS 2025, we humbly thank you for your kind acceptance during this time. Thank you, ma'am.
Okay, so thank you once again, and I need to leave this meeting. Is it okay?
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Okay. So
Thank
thank you. Thank you.
Participants, please gather for a group photo at the entrance of the College of Education. Afterward, you will have a break for 20 hours. Kindly return to the hall for the second session.
Professor, Department of Computer Science, to deliver the welcome address and introduce the keynote speaker.
Good morning to one and all. It is my with immense joy and pride I extend a warm and heartfelt welcome to our distinguished resource person, Dr. G. Mahadevan, Professor, Department of Mathematics, Gandhigram Rural Institute, Gandhigram, and Director, Center for Visiting Experts and Professor of Practice. Dr. Mahadevan is an eminent academician and researcher with more than 3 decades of rich teaching and research experience. He has guided 11 PhD scholars and 53 MPhil scholars and continues to mentor many more. With an impressive record of over 160 research publications, 12 book chapters, and 4 author books. He has significantly contributed to the advancement of mathematical science. His expertise and scholarly contributed are recognized globally, having delivered invited talks at prestigious international universities across Singapore, Dubai, Vietnam, Cambodia, Malaysia, and Thailand. He has also served as an associate editor and guest editor for reputed international journals and conferences. In addition to being reviewer for leading journals, including Springer, Nature, Singapore. Dr. Mahadevan academic leadership is equally commendable. He has held key positions such as head of mathematics at Anna University of Technology, Tirunelveli, and at Dr. Shivandi Adityanar College of Engineering, Tiruchendur. At present, he also serves on a board of management, planning and monitoring board and academic council of GRI DTB, beside being a member of several prestigious academic research bodies. His exemplary work has earned him numerous awards, including the Indo-Asian Henry Panikkar Distinguished Research Award 2022. Dr. APJ Abdul Kalam Award for Scientific Excellence 2015. Best Scientific Award 2016 to 2017. And Lifetime Achievement Award 2019, among many others. Sir, we are truly honored by our gracious presence among us today. On behalf of the organizing committee of ICRTMCS 2025, I extend our warmest welcome to you and look forward to your inspiring address, which I am sure will enrich and enlighten us all. Welcome, sir.
Thank you, ma'am, for your warm words of welcome and felicitations. Now it is my honor to invite our chief guest, Dr. Magadevan, Professor and the Head of Mathematics, the Gandhigram Rural Institute, Gandhigram, to take over this session. Welcome, sir.
So very good morning to all. Sound இல்லையே? Okay. First of all, I would like to thank the Almighty and the principal and the HOD and other faculty members of this college for giving me the opportunity to share some of the real life applications of graph theory. Okay, I am not here to derive something or prove something, right? The definition, theorem, proof, எதுவுமே கிடையாது, right? Function. BSc Max and MSc Max students கை தூங்க. Okay. Function, continuous function, uniform continuous function, open set, closed set, எந்த புண்ணாக்கும் கிடையாது. ரைட்டா? The subject graph theory deals with the tremendous applications in real life. Without application, you cannot be fruitful in your life, right? நீங்க எக்ஸாம் படிக்கிறீங்க, முடிச்சு இன்டர்வியூ போறீங்க, எந்த இன்டர்வியூமே ஸ்டேட் அண்ட் ப்ரூவ் ஃபண்டமெண்டல்ஸ் ஆல்ஜிப்ரா கேட்பானா? கேட்க மாட்டான். ஒரு இன்டர்வியூ போறீங்க, டிஃபைன் ஓப்பன் செட் அப்படின்னு கேட்பானா? சத்தியமா கேட்க மாட்டான். ரைட்டா? இந்த தியரம், ப்ராப்ளம் இதெல்லாம் மெமரைஸ் பண்ணி வாமிட் பண்ணி எக்ஸாம்ல மார்க் வாங்க மட்டும் தான் யூஸ் ஆகும். You may get 100%, 99.9% in your BSc or MSc. Dear students, just getting very high mark in your MSc and BSc will never give you a job. Right? இன்னைக்கு இருக்க டெக்னாலஜிக்கல் வேர்ல்ட்ல யாருமே பயோடேட்டே பார்க்க மாட்டாங்க. Once you enter the campus, they will throw a piece of paper in the form of entrance examination. Quantitative aptitude test, right? அதுல கிளியர் பண்ணா மட்டும்தான் the company want to see the biodata of yourself. It's a competitive world. You can memorize many things and vomit. You may get good marks. That alone will never give you a job. You must see the application side, where we use the concept of mathematics, especially graph theory, in our real life. ஒரே ஒரு கொஸ்டின் மட்டும் கேட்கிறேன். ஒரே ஒரு கொஸ்டின். ஒரு இன்டர்வியூல கேட்ட கொஸ்டின், integral 1 to 2 x dx. கஷ்டமான கொஸ்டினா? நீ டபுள் இன்டெகிரல், ட்ரிபிள் இன்டெகிரல் படிச்சிருப்ப, ஹெய்ன்போர்ன் தியரம், டோபாலஜி, ஃபண்டமெண்டல் வல்ஜியம் படிச்சிருப்ப. ஒரு இன்டர்வியூல கேட்ட கொஸ்டின், integral 1 to 2 x dx. என்னப்பா ஆன்சர்? அவுட் ஆஃப் போஷனா? ஒண்ணா? வெரி குட், கிளாப் பண்ணுங்கப்பா. ஸ்டாப் இட். கிளாப் வாபஸ் வாங்கிக்க. எப்படி ஒண்ணு வரும்? இன்டெகிரல் லோயர் லிமிட் 1 அப்பர் லிமிட் 2 x dx. எப்பா நான் இன்டெகிரல் கேட்கேன். எனிபடி? 3/2 அதான் கரெக்ட். இன்டெகிரல் x dx என்ன ஈக்குவல் டு x ஸ்கொயர் பை 2. 1/2 எடுத்துரு. x ஸ்கொயர் லிமிட் 1 to 2. அப்ப 1/2 ஆஃப் 2 ஸ்கொயர் மைனஸ் 1 3/2. ரைட்டா? இந்த 3/2ல ஈஸியா சொல்லிடுவேன். ஆனா உனக்கு ஜாப் கிடைக்காது. அவங்க அது கேட்கல. என்ன கேட்கான்னா, that 3/2 represents what? What's the geometrical meaning for that 3/2? அதான் கொஸ்டின். நீ இன்டெகிரல் கால்குலஸ் சென்டம் வாங்கியிருப்ப, just to memorize and by heart and vomit in examination. But interviewல integral 1 to 2 x dx equal to 3/2. That 3/2 represents what? What is the geometrical meaning for that 3/2? Anybody? Are you able to follow my question? Question புரியுதா? Question புரியுதாமா? The 3/2 எதை குறிக்குது? What is the meaning for that? See where you are. Integral calculus சென்டம் வாங்கியிருப்பீங்க. But the 3/2 represents what நமக்கு தெரியல. Anybody? அது எதை குறிச்சா எனக்கு என்ன சார் சொல்லக்கூடாது. அப்பா 3/2 1.5 எனக்கும் தெரியும். அந்த 1.5 என்ன மீனிங்? What is the geometrical meaning for that? அது 1.5 எதை குறிக்குது? எதை குறிச்சா எனக்கு என்னவா? கிராஃப குதிக்குதா? வேற 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 என் கொஸ்டின் அது இல்ல. இன்டர்வியூ கேட்கிற கொஸ்டின் வந்து ஒரு பொண்ணு 99.9% கோல்டு மெடலிஸ்ட் இன் எம்எஸ்சி இன்டர்வியூ போறீங்க. இந்த கொஸ்டின் கேட்கறாங்க. வாட் இஸ் த மீனிங் ஃபார் தட் 1.5? வாட் இஸ் த ஜியோமெட்ரிக்கல் மீனிங் ஃபார் தட் 1.5? நீ சொல்ற, நான் சொல்லவா? That 1.5 represents the area of the curve y is equal to x between the point x equal to 1 to x equal to. கரெக்டா இல்லையா? கரெக்டா இல்லையா? அதைத்தான் எழுதி பார்க்கலாம். அப்ப இன்டெகிரல்ங்கிறது ஏரியா ஆஃப் தி கர்வ் y equal to x between 1 to 1 to 2. இந்த இன்டெகிரல் கால்குலஸ்ல செண்டம் வாங்கி என்ன பிரயோஜனம்? விட்டுருவோம். sin theta by cos theta என்ன வேல்யூ? sin theta by cos theta யார் சொன்னா? நான் இல்லன்றேன். will you accept? will you accept? ஏதோ டீல போடுவோம். நான் sin theta by cos theta not equal tan theta சொல்றேன். யாரெல்லாம் அக்செப்ட் பண்றீங்க? ரைஸ் யுவர் ஹேண்ட். sin theta by cos theta not equal tan theta யாரெல்லாம் அக்செப்ட் பண்றீங்க? நான் ப்ரூஃப் கொடுக்குறேன். will you accept? I will give you a proof for sin theta by cos theta not equal to tan theta. will you accept? ஏதோ விசாரணை சொல்லு. பாதி பேர் எஸ், பாதி பேர் நோ சொல்றீங்க. சரி, நீ ப்ரூஃப் கூட அக்செப்ட் பண்ணிக்கிறேன். sin theta by cos theta equal to tan theta. யாராவது can you give a proof for it? யாராவது சொல்ல முடியுமா? சீக்கிரம் 1 minute தான் டைம் இருக்கணும். sin theta by cos theta equal to tan theta. இதான் சார் ப்ரூஃப் அப்படின்னு சொல்ல முடியுமா? Because being a mathematician, without proof, I won't accept anything. Anybody is ready to give the proof? I will give 1,000 rupees immediately. I will give 1 rupee that equal to 1,000 rupees. Anybody? யாரும் willing இல்ல. சரி, இப்ப நான் சொல்றேன் sin theta by cos theta not equal to tan நான் ப்ரூஃப் பண்றேன். will you accept? will you accept? ரைட். அப்ப என்ன, இதுக்கப்புறம் வர எல்லா செமஸ்டர்லயும் நீ என்ன பண்ணணும்? sin theta by cos theta நாட்டுக்கணும்னு எழுதணும். ஓகேவா? எல்லாம் அறியறதுக்கு அப்புறம் பரவாயில்லையா? பேணுமா? ஸ்ரீதர்ஷினி எழுத எல்லா எக்ஸாம்லுமே sin theta by cos theta not equal to tan எழுத போறா. சோ பெட்டர் லக், நெக்ஸ்ட் டைம் ஆயிடக்கூடாது. ஒரு எக்ஸாம்ல கேட்ட கொஸ்டின் சிம்பிளிஃபை. கொஸ்டின் வந்து simplify. Some complicated questions arises. Some sin, cos, tan, secant, cosecant. At the end of the last page, that girl wrote sin theta by cos theta equal to that girl cancel theta s அடிச்சிட்டா. sin theta by cos theta ல s அடிச்சிரு, theta அடிச்சிரு equal to in by co. So sin theta by cos theta equal to in by co. அவன் என்கிட்ட வந்து ஏன் சார் கொஸ்டின் இஸ் சிம்பிளிஃபை, சோ ஐ ஸ்மில் பட்ட அப்படி சூசைட் பண்ண பார்த்தா மேல ஃபேன் ஒண்ணு இல்ல. அன்னைக்கு அந்த காலேஜ் விட்டு வெளியே வந்துட்டேன். அதுக்கப்புறம் தான் ஐ கேம் டு நோ தட் sin theta by cos theta not equal tan theta, it is in by co. இதாவது பரவாயில்ல, நம்மால் இன்னும் கொஞ்சம் பேர் இருக்கான் dy by dx ல dd அடிக்கவனா இருக்கான். ரைட்டா? dy by dx அடிச்சுட்டு dd அடிச்சலாமா? ஏக்கா அப்படி அடிக்க கூடாது. dy by dx dd அடிக்க முடியாது. So such students are there. I hope you are not in that category. Hope you are not in that category. Come to the point. Today we are facing many problems in our real life. Many problems in our life. Either physical, mental, marriage, many problems. Marriage is a very big problem. Even that problem can be solved with the help of graph theory. What we do is, you convert any real life problem into graph theoretical language by the way of vertex and edges. Vertex and edges. Then depending upon the nature of the problem, you choose any one of the parameter, apply it, get the result and interpret with that the physical situation. That is the beauty of graph theory. நீ ஃபேஸ் பண்ற எல்லா பிரச்சனைக்கும் சொல்யூஷன் உண்டு. எப்படின்னா உங்களுடைய ரியல் லைஃப் ப்ராப்ளம் இருக்குல்ல, இந்த ரியல் லைஃப் ப்ராப்ளத்தை கிராஃப் தியரிட்டிக்கலா மாத்துறீங்க. எப்படி? பை வே ஆஃப் வெர்டெக்ஸ் அண்ட் எட்ஜஸ். Then you will get a beautiful graph structure. There are so many existing parameters are available in literature. Depending upon the nature of your problem, you choose any one of the parameter, apply it, get the result, and interpret with that the physical situation. That is the beauty of mathematics. ஒரு சின்ன எக்ஸாம்பிள் சொல்றேன். உன்னை அறியாமல் உன்னுடைய ஒவ்வொரு நடவடிக்கையும் கண்காணிக்கப்படுகிறது. சே சார் நோ. நீங்க நினைச்சிட்டு இருக்கீங்க இன்னைக்கு ஹெச்ஓடி லீவு, பிரின்சிபல் லீவு, ஃப்ரெண்ட்ஸ் இல்ல, நீ கேம்பஸ் குள்ள என்ன வேணாலும் பண்ண நினைப்பீங்க. நடக்காது. நீ இந்த கேம்பஸ் குள்ள என்ன பண்ற, யார்கிட்ட பேசுற, லைப்ரரி போறியா, இங்க இருக்கியா, பாய் ஃப்ரெண்ட் பேசுறியா, கேர்ள் ஃப்ரெண்ட் பேசுறியா, எல்லாமே வந்து without being a physical presence, the management by the principal or secretary or the dean can be watched by you sitting in US or flight. Is it possible or not? Possible இல்லையா? எப்படி possible? எப்படி possible? CCTV camera, right? CCTV camera, right? Now your ICRTM college, a very big college, very beautiful campus consisting of many classrooms, labs and all. The question is, I want to safeguard the ICRTM college by fixing CCTV camera. Now the question is, how many minimum number of CCTV cameras are required? Not only how many, where we have to fix it. Correct இல்லையா? நீ 100 கேமரா வாங்கி வைக்க முடியாது, 50 கேமரா வைக்க முடியாது, ஒன்னே ஒன்று வைக்க முடியாது. சரியா? இப்ப என்னன்னா, if you want to install one CCTV camera, it requires lakhs and lakhs rupees, right? I want to depute or fix a minimum number of CCTV cameras in such a way that the entire ICRTM College of Arts and Sciences are women under the control of a single mobile or TV. Right? It's a real life problem. Amma இல்லையா? How many minimum number of CCTV cameras are required to safeguard your college? It's a real life problem. How to solve the problem? Your physics, your chemistry, your zoology will never solve the problem. Mathematics, especially graph theory, has got fantastic solution to the real life problem. Am I correct? What we do is, you convert this into graph model by way of vertex and the edges. Then there are so many existing parameters are available. Depending upon the nature of the problem, you choose one parameter called a dominating set. Sir, what is dominating set? What is domination number? That's a different issue. Forget about it. Okay. You choose, you find the dominating set of the graph theoretical representation of this problem, find the number, and that is the answer for it. So what I wanted to communicate with you is, the solution of this real life problem is nothing but finding the domination number of the graph theoretical representation of real life problem. Right? Right? The same problem can be remodified in many ways. How many minimum number of cell phone towers are required in order to give hassle-free network connection to all over the world? நீங்க வேர்ல்டு ஃபுல்லா செல்போன் கனெக்ஷன் கொடுக்கணும். நீங்க எங்கேயாவது பார்த்திருக்கியா? ICRTM காலேஜ் என்ட்ரன்ஸ் ஒரு செல்போன் டவர், பக்கத்து வில்லேஜ் ஒரு செல்போன் டவர், அப்படி பார்த்திருக்கியா? இல்ல. ஒரு செல்போன் டவர் இருந்ததுன்னா the cellphone tower can send or receive signal up to certain radius, right? Now if you want to give hassle-free network connection to all over the world, I have to install cell phone tower in some of the places, right? I cannot install cell phone tower in many places or randomly places. Now the question is, how many minimum number of cell phone towers are required? Not only how many, where we got to fix. Is it real problem or not? Napa? Is it really problem or not? Problem தானே? ஆமாவா இல்லையா? How to solve the problem? Your physics, your chemistry, your zoology, your botany, your Tamil, your English, biotechnology will never solve the problem. Mathematics, especially graph theory, has got fantastic solution to solve this real life problem. What we do is you convert this into a graph model by way of vertex and edges, applying the suitable domination parameter, get it, and that is the answer for it. Right? So the solution of this fixing the minimum number of cell phone tower is nothing but finding one particular domination parameter of the problem. So the same problem can be resolved in many ways. Today we are facing threat by nearby countries, right? If Pakistan இருந்து நம்ம இந்தியாவை அட்டாக் பண்ண ஒரு மிசைல் வருதுன்னா within a fraction of second our missile will go and attack. எடுமா our missile will go and attack. Right இல்லையா? Suppose our enemy missile comes into our body. Our enemy missile comes enter into our area. Within a fraction of second, our missile will go and attack. So that type of technology is there. Right? Within a fraction of second. Once you give a command, our missile will go and attack. Right? The backbones are mathematics, especially graph theory. Google Map depends upon graph theory. Location map depends upon graph theory. Right? உன் நேம் என்னமா? சக்தி. சக்தி என்ன பண்ணிருக்காங்கன்னா வீட்டுல இருந்து வந்துட்டு காலேஜ் போய் சொல்லிட்டு வந்துட்டா உட்காரு. தெரியுமா? ஒரு பேச்சு வச்சுக்கோமா பயப்படாத. ஆனா காலேஜுக்கு போற ஃப்ரெண்டு வீட்டு போயிருக்கா. உங்க அப்பா கால் பண்றாரு. எப்ப நான் காலேஜ் இருக்குன்னு சொல்றா. மாட்டிப்பால மாட்டிக்க மாட்டாளா? கேமரா கிடையாது. சக்தி வீட்டுல இருந்து கிளம்பி வரப்பல காலேஜ் அழக்கூடாதுமா. காலேஜ் வரப்பல ஆனா ஃப்ரெண்டு வீட்டுக்கு போயிடாப்ல. அப்பா கால் பண்றாரு. எங்கம்மா இருக்கேன்னு கேட்கிறாரு. நான் காலேஜ் தான் இருக்கேன்னு சொல்றா. மாட்டிப்பால மாட்டிக்க மாட்டாளா? மாட்டிக்க மாட்டா. கேமரா கிடையாது. மாட்டிக்க மாட்டா. ரைட்டா? ரைட்டா? மாட்டிப்பா. ஏன்னா அவருக்கு கூகுள் ட்ராக்கிங் சிஸ்டம் இருக்குல்ல, அந்த ட்ராக்கிங் சிஸ்டம் பார்த்தீங்கன்னா சக்தி உன் ஃப்ரெண்டு வீட்டில தான் நீ இருக்க, இந்த பிளேஸ்ல இருக்க, ஆனா காலேஜுக்கு போய் அவங்க அப்பா கண்டுபிடிச்சிருவாரு. அதனால வீட்டுல இருந்து வெளியே போகும்போது செல்லை எடுத்து லொகேஷன் ட்ராக்ல போய் ஆஃப் பண்ணிடணும். புரியுதா? சோ இந்த செல்லு வந்து மிகப்பெரிய ஒரு வரப்பிரசாதம் ஆஸ் வெல் அஸ் நெகட்டிவ் பாயிண்ட். சரியா? லொகேஷன் ட்ராக்கிங் ஒண்ணு இருக்கு. அந்த லொகேஷன் நீ எங்க இருக்க, என்ன பண்ற, உன்னோட ஒவ்வொரு நான் இங்க நடந்தா கூட என் ஒய்ஃப் பார்த்துட்டு இருப்பா. முடியாதா? இல்ல நீங்க ஏன் சேர்ல உட்கார்ல நடந்துட்டு இருக்கீங்க, மெசேஜ் போடுவா. ஏன்? கூகுள் இருக்கு. ரைட்டா? அதனால நீ சேஃபா இருக்கணும்னா வெளியே போகும்போது செல்லை எடுத்து லொகேஷன் போய் ட்ராக்கிங் சிஸ்டம் ஆஃப் பண்ணி வச்சுக்கணும். ஆமாவா? So the backbone of the technology is mathematics, especially graph theory. So what I wanted to communicate with you is, இன்னைக்கு இருக்க tremendous technological worldல morning I can have a breakfast at Thailand, afternoon lunch with the US, dinner breakfast at ICRTM college. முடியாதா? முடியும். எதனால? flight. ரைட்டா? இந்த flightக்கு we don't think that the pilot is a genius. If you want to fly from ICRTM college to Singapore, அந்த பைலட்டுக்கு ரூட் தெரியுமா? இங்க எது போலாம், ஒரு சாயங்கள் நிப்பாட்டிக்கலாம், பஸ்ஸால் நிப்பாட்டி போற பைலட் தெரியுமா? எதுவுமே தெரியாது. அந்த at the entrance of the airport, the pilot starting point Chennai airport, ending point Singapore. Immediately the Google will give a excellent shortest path in the monitor. Right? The job of the pilot is just you take off the flight, keep on the flight in the line which is available in the monitor, then land off. That's all. So the backbone of every technology is mathematics, especially graph theory. Now come to the point of medical field. Graph theory has got fantastic application not only in electronic item but also in human relations. We are human. We have ifan buts. Today I may be a good friend of you. Tomorrow I may be a bad friend of you. Because in between that 1 hour or 12 hours, he may receive a lot of information about both in good side as well as the bad side. Immediately, the neurons in your brain, immediately the neurons in your brain will change and you can take the decision. Immediately you can change. Graph theory has got fantastic application for solving human-related problem. Our men anatomy and female anatomy can be modeled as a graph. Men body, female body can be modeled as a graph because our body consisting of bones and joints, right? Bones and joints. உன் பாடியில நிறைய ஜாயிண்ட் இருக்கா, போன் இருக்கா, அந்த ஜாயிண்ட் எல்லாம் வெட்டஸா வச்சுக்க. ஜாயிண்ட் எல்லாம் வெட்டஸா வச்சுக்கோ. If a bone is connecting from one joint to other joint, put an edge. Put an edge. In this way, you can obtain a beautiful graph structure of men anatomy and human anatomy. Am I correct? Am I correct? Then you can apply some algorithm, solve it, get the result. That is the answer for many medical problems. Like brain tumor, blood cancer, breast cancer, eye cancer, abdomen cancer, many problems can be solved. Even a heart problem can be solved with the help of graph theory. Dear students, don't think that a doctor is a very genius person in this world. Doctor is a genius person in the world. உன் பேர் என்னமா? உன் பேரு ஆஃப்ரின் சகானா. சகானா வச்சுக்கலாம், சரியா? ஆஃப்ரின் கட் பண்ணிடலாம், கஷ்டமா இருக்கு சொல்றதுக்கு. சகானா என்ன பண்றாங்க? ஹாஸ்பிட்டல் போறாங்க, சரியா? பயந்துடாதம்மா. ஹாஸ்பிட்டல் போறீங்க, சகானாவை பார்த்த உடனே டாக்டர் வந்து உனக்கு ஹார்ட் ப்ராப்ளம் இருக்குமா, நீ டிக்கெட் வாங்கிடுவ அப்படின்னு சொல்லுவாரா? சொல்லுவாரா? அவளுக்கு ஹார்ட் இருக்குன்னு வச்சுப்போம், சொல்ல முடியுமா? சகானா ஹாஸ்பிட்டல் போயிட்டு ஹார்ட் ப்ராப்ளம், செஸ்ட்ல பெயின் இருக்கு, ஹாஸ்பிட்டல் போயிட்டு நீ டாக்டர் தானே கண்டுபிடியா பாப்போம் அப்படின்னு சொல்லுவாள? ஹாஸ்பிட்டல் போய் உட்காந்துருக்கீங்க, எனக்கு என்ன நீ சொல்லியா? சொல்ல முடியுமா? முடியாது. ஒன் சகானா என்டர் த ஹாஸ்பிட்டல், அழக்கூடாதுமா, ஒன்னு சும்மா சொல்றேன். ஒன் சகானா என்டர் த ஹாஸ்பிட்டல், த டாக்டர் பிரிஸ்கிரைப் மெனி டெஸ்ட், அப்படிதானே? இசிஜி, எக்கோ, மெனி டெஸ்ட் எடுப்பார். இந்த டெஸ்ட் எல்லாம் பேஸ் பண்ணி ஒரு பயாலஜிக்கல் ரிப்போர்ட் கொடுத்து ஒரு மேனிபுலேட் பண்ணி he will get a report, right? அந்த ரிப்போர்ட்டை பார்த்து தான், if that report exactly matches with the existing medical records, the doctor may suggest, Sakana, don't worry, you have no problem. If the report slightly modified to the existing data, he may say, Sakana, you have a problem of heart attack very soon, be careful. If the report deviates very long, doctor says, Sakana, no choice, pray to God, you will get a ticket like this. If a report matches off, etc., you need bypass surgery immediately. Like that, tell. That's why I'm telling doctor is not a job. God. Just because of see your face, because of your body, the doctor will never give you a solution. Right? The backbone of the technology is nothing but graph theory. Just I want to show only one picture. Time na sir. Time பாருங்க. 27. கரெக்டா 40 சொல்லுங்கண்ணே. என்னமா? கேட்கல? ஹார்ட் மென் ஹார்ட்டா ஃபீமேல் ஹார்ட்டா? இது மென் ஹார்ட்டா ஃபீமேல் ஹார்ட்டா? ஃபீமேல் ஹார்ட்டா? ஹியூமன் ஹார்ட்டா? வா, சரி, ஹியூமன்ல மென் இருக்காங்க, ஃபீமேல் இருக்காங்க. இப்ப சொல்லு, எது ஹார்ட்? ஹியூமன் மென் ஹார்ட்டா, ஹியூமன் ஃபீமேல் ஹார்ட்டா? Human men heart or human female heart? நார்மல் ஹார்ட்டா? சரி, அப்ப அப்நார்மல் ஹார்ட் ஒன்று இருக்கா? சரி, ஹியூமன் நார்மல் மென் ஹார்ட்டா, ஹியூமன் நார்மல் ஃபீமேல் ஹார்ட்டா? சீக்கிரம். சீக்கிரம். 1 minute டைம். எப்படி சொல்ற? ஃபீமேல் ஹார்ட்டே கிடையாதுமா. இது என்லார்ஜ் பண்ணுங்க. இது என்லார்ஜ் பண்ணுங்க. இதை கொஞ்சம் என்லார்ஜ் பண்ணுமா. என்லார்ஜ் பண்ணணும். பேக் போ. பேக் போமா. உனக்கு தெரியாதா? தெரியாதா? இருமா. பேக். இன்னும் கொஞ்சம் குறைச்சு. இன்னும் கொஞ்சம் கொடு. இன்னும் கொஞ்சம் கொடு. இன்னும் கொஞ்சம். கொஞ்சம் மேல கொடு. ரொம்ப சொல்லிட்டேன். ரைட் விட்டுரு. ஓகே சொல்லமா. மென் காட்டா ஃபீமேல் காட்டா? ஃபீமேல் ஹார்ட் சொல்லிட்டேன். ஐ ஹாவ் நோ ஹார்ட். வில் யூ அக்ரி? எனக்கு ஹார்ட்டே கிடையாது. எனக்கு ஹார்ட்டே இல்ல. எஸ், ஏன்னா என் ஹார்ட் என் ஒய்ஃப் கிட்ட பத்திரமா இருக்கு. ரைட்டா? இல்லப்பா. ரைட். லிசன். Say both men and women heart are same. ரைட்டா? Both men and women heart are same. உன் ஹார்ட்ல 24 ஹோல்ஸ் இருக்கு. 24. அது வாசி பார்க்கலாம். ஃபர்ஸ்ட் என்னது? அரோரா. வாசி. அரோரா, பல்மோரே ஆர்டரி, left atrium, mitral valve, aortic valve, left ventricle, right ventricle, IVC, valve, right, etc. Right? These are all the holes of your heart. Right? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 etc. Some more points are there. Okay, some more are hidden. If the holes are available, put a vertex. The blood is flowing inside the heart. Suppose the blood is flowing from left atrium to right pulmonary artery, put an H, otherwise don't put an H. Right? If the blood is flowing from one point to other point, we can put an H, otherwise don't put an H. In this way, you can obtain a beautiful graph structure. Am I correct? So now I have to convert our human heart into graph theoretical model as vertex and edges. Your heart consisting of many holes and many paths are there. Put the holes are the vertices. If a blood is flowing from one part to other part, you can join an edge. Otherwise, don't join an edge. Blood should flow in particular way only. If it is not reverse, okay. One heart like kundaka mandaka blood pogadu. Adu pochina ticket தான். ஒரு பர்டிகுலர் பாத்ல மட்டும் தான் போயிட்டு இருக்கும். ரைட்டா? You can put a directed graph. Like this. Say this is the directed graph of your human heart. This is the directed graph of your human heart. So how to convert your heart into graph, that I will show it in this slide. See, Vasipa, let V equal to Vasi, let V equal to V1 to VI with the vertices of a directed graph of the normal heart. that are as follows. What is V1? V2? V3? V4? V5? V6? V7? V8? V9? V10? Yes, proceed. V11? V12? V13? V14? V15? V16? V17? V18? V19? V20? V21? V22? V23? V24. Right? These are the technical terms of a human heart. Put that vertices, right? If your blood is flowing from, as I already told you, if your blood is flowing from one part to other part, you can join an edge, otherwise don't join an edge, right? In this way, I can obtain a beautiful, for example, say how to form a edge. The vertex V24 represents all organs involved in systematic circulation, such as brain, organs, and soft. These are technical terms, okay? Medical terms. For example, if your blood flows from RA to RV, what is RA? Right artery, RV, right ventricle, right? If your blood is flowing, the other that we don't know. It is inside our cardiologist can know. The cardiologist can know in which part the blood is flowing. He know all the medical terms. If the blood is flowing from one particular part to another particular part, you can put an edge. For example, V3 to what is V3? RA. What is V4? RV. If your blood is flowing from RA to RV, I can put an edge. If it is RA to RV, put an arrow mark like this. If it is reverse, put an arrow mark reverse like this. Okay. In this way, I can obtain a beautiful graph structure. Right? The first stage is what's the first stage? I have to convert. Once the Sagana enters the hospital, the cardiologist should prescribe many tests, right? ECG, echo, everything. That are all under graph theory only. Based upon the existing data or some manipulation, they will get a sheet. First one is they convert this into graph model by a way of vertex and the edges. Then applying suitable algorithm or manipulation, this graph can automatically go into adjacency mode like this. So I will come to a part. Okay. So these are all the technical terms. Just I forgot to it. I can skip because of the many lack of time. This is after manipulating certain things, I will get a matrix like this. I will get a matrix like this. Right? So I will get a, what is this? Adjacency matrix, right? Adjacency matrix. So this is the adjacency matrix of our human heart. Again, he puts a manipulation. I can get some more manipulation, some more algorithm. That you can forget about it. Some more manipulation, some algorithm. I will get a graph like this. Now you count number of ones, 1, 2, 3, 4, 5. Now the cardiologist tell your heart having 5 blocks are there. You need immediate either bypass surgery or stent. Okay. So this is the technology in which the doctor can able to perform excellent way. What I forget about the medical term, what I want to communicate to you is the backbone of this technology is nothing but graph theory. Right? The backbone of it is nothing but graph theory. Not only in heart problem, but also in many problems, even cancer problem, especially for breast cancer. The cancer cells are the vertices, right? If one cancer cells affect the nearby cancer cell, you can put an edge. I don't put an edge. Now we got to decide which edge has to be removed so that this cancer cell will never attack the nearby cancer cell. Nothing but graph theory. Right? So knee problem. So next one is this is the shunt. And again the knee problem, we will use graph theory. Yeah, in medical term, how to replace your knee based upon your damages in your both left knee and right knee, and exact the place in which we got to fix a new knee, nothing but graph theory. Right? Even brain network we can use graph theory. So graph theory has got fantastic application in medical field. That's why I'm telling that not only in electronic item, but also in human being. Whatever may be the medical problem, Graph 3 has a solution. That means the Graph 3 has got excellent technique or excellent result in which the surgeons, oncologists can proceed further. Go to Google, type it, you will get excellent mathematical background of medical. Just to go to Google, type it, applications of Graph 3 in medical field, you will get excellent field. Graph 3 has got excellent application in jail also. நீ கேட்டு ஜெயில எங்க சார் கிராஃப் யூஸ் ஆகுது? The jailer always have an eye to the prisoner not to escape. The prisoner always have an eye to jailer how to escape. இந்த ஜெயில கைதி போலீஸ பார்த்துட்டே இருப்பான். அவன் அழகா இருக்கேன்னு பார்க்கல, இவன் எப்படா தூங்க எஸ்கேப் பார்த்துட்டு இருப்பான். ரைட்டா? போலீஸ் கைதியை பார்த்துட்டே இருப்பான், இவன் அழகா இருக்கேன்னு பார்க்கல, இவன் எஸ்கேப் ஆயிட்டா வேலை போயிடும். சரியா? They will have one-to-one correspondent. There we put the concept of matching. Matching is a subset of edges in which no two edges are adjacent. Then you go for perfect matching. A matching set to be perfect if the index of graph has no isolated points. Right? Matching is a subset of edges in which no edges are adjacent. A matching that saturates all the points are called a perfect matching. The concept of perfect matching plays a vital role which has got tremendous application in real life. Yesterday, I think Professor Armugam delivered an excellent lecture. I am a student of Professor Armugam, sir. And we introduced one concept called complementary perfect domination number of a graph, which has got excellent application in developing model villages. In India, due to poverty and an unemployment problem, people are moving from villages to metropolitan cities, which are far away. So in order to give facilitate to all the facilities, we have to concentrate only certain villages, so that you can give transport and fill to all those villages. Between them, a road is already there, they can interchange. So the question of how to construct a model village with the minimum cost is nothing but finding the complementary perfect domination number of the graph theoretical representation of real life problem. Right? Similarly, as I already told you, finding the minimum number of CCTV camera to safeguard the entire axiom code, nothing but finding the one particular parameter of the graph theoretical representation of the real life problem. Dear students, don't think that graph theory has got fantastic application not only in electronic item, not only in medical field, but also in human relations. As I already told you, we are human beings. We have different buds. Today I may be a good friend of you. Tomorrow I may be a bad friend of you. Because in between the 12 hours, you may receive lot of information, either in good sense or bad sense. Immediately you change your decision. Right? Suppose you want to safeguard the entire Axiom College by deputing security person, not CCTV camera. You can think in that side also. நம்ம என்ன சொன்னோம், இந்த என்டையர் காலேஜை சேஃப்கார்ட் பண்றதுக்கு மினிமம் நம்பர் ஆஃப் கேமரா ஃபிக்ஸ் பண்ணா போதும். ரைட்டா? Your principal or your secretary or management staff, they can sit in flight or their cabin, just to take the mobile and see it. Entire college comes under the control of single CCTV, right? It is possible because of CCTV camera. The question is, you have to convert your Axiom College into graph model by way of vertex and edges. Then finding one particular parameter, forget about the parameter, that's the answer for it. Now you forget about CCTV camera. Human being. I want to safeguard the entire Tanjavur district, right? Tanjavur district have many streets and houses and apartments are there. I want to depute security persons in some of the places so that the entire area should be covered. Remember, not CCTV camera, it is human being. If we depute one security person at one junction of the place, that security person can able to safeguard up to one block only, right? If Axiom College entrance of security officer nipatna, that security officer, because of his age, because of high vision, the security officer can able to safeguard up to one block only, right? நீ கேட்ல வச்ச செக்யூரிட்டி ஆபீசர் ஹாஸ்டல் பார்க்க முடியுமா? முடியாது. அவனோட ஏஜ் அவனோட ஐ விஷன் தக்கல the security officer can safeguard up to one block only. I want to safeguard the entire Axelium college by deputing security person. Now the question is, how many minimum number of security persons are required to safeguard the security officer? நீங்க நினைக்கலாம், ஏன் சார் சிசிடிவி கேமரா வச்சு நினைக்கலாம்ல? 45. So CCTV, why we put security officers? We got to put CCTV camera. Not like that. If you put CCTV camera, if the fire is going on inside the campus, what the CCTV camera will do? Fire is going on, focus பண்ணி காட்டிட்டு இருக்கும். சாலாகுமா? சாலாகாது. அங்க சேர் மூலம் மேனேஜ்மெண்ட் போர்டு உட்கார்ந்து பார்த்துட்டு இருப்பாங்க, ஃபயர் போயிட்டு இருக்கு பார்ப்பாங்க. ஆனா if you deputy security officer, immediately the security officer will come down and solve the problem, right? So still lot of openings are there due to research in all the problem. Go to Google, type it, you will get excellent application graph theory. Dear students, in a nutshell, whatever may be the problem that you are going to face, either physical, mental, whatever it may be, is solvable. Only thing is, you must know how to convert your physical or mental problem into graph theoretical language by way of text and edges. Then, depending upon the nature of the problem, you choose any one of the parameter, apply it, get the result, and interpret with the physical situation. That is the beauty of graph theory. Still, lot of openings are there. Feel free to call me at any time. You can go to my website, you will get it. Thank you. Thank you.
Thank you so much, sir, for your excellent presentation on exploration of real-life applications through graph theory from digital solutions to medical innovations, and sharing for your invaluable knowledge and expertise with us today.
Are there any questions or clarifications from the participants? We are truly honored by your presentation and presence. We now humbly request you to remain on stage as we present a certificate and token of appreciation. Thank you once again for your insightful session.
May I invite Ms. Sandana Rogini, Department of Computer Science, to propose the vote of thanks.
Respected Dr. G. Mahadevan, distinguished participants, faculty members, and dear students, it is my privilege to extend a heartfelt vote of thanks after the insightful lecture delivered by our esteemed resource person, Dr. G. Mahadevan, Professor of Mathematics, Gandhigram Rural Institute, Gandhigram, and Director, Center for Visiting Experts and Professors of Practice. Sir, your thought-provoking address on the theme Exploration of Real-Life Applications through Graph Theory from Digital Solutions to Medical Innovations was truly enlightening. You have brilliantly demonstrated how the beauty of mathematics extends far beyond theory, providing solutions to real-world challenges ranging from technology to healthcare. Your presentation has not only deepened our understanding of graph theory, but also inspired us to appreciate its vast interdisciplinary impact. On behalf of the organizing committee of ICRTMCS 2025, I sincerely thank you for accepting our invitation despite your many commitments and for sharing your expertise with us. Your words have undoubtedly ignited curiosity and motivation among researchers and students alike. We are deeply grateful to you, sir,
for your valuable time, scholarly contribution, and inspiring presence, which have greatly enriched the conference. Thank you once again, sir.
Thank you for your vote of thanks. Participants, it is now time for your lunch break. As per the schedule, please return to the hall for the valedictory function. Thank you.